This is the Benioff zone and the earthquake focus. You see here that the oceanic crust is heavier than the continental crust. So what's happening is that since the oceanic crust is heavier, when the two collides through the convergent boundary, the heavier one sinks. Just like what's happening here, the heavier one sinks, and the scratching, the friction between this and this produce stress and stress that builds up until the rock breaks here. And this is where what the Benioff zone is located, and this is where also the Benioff zone is located in the other picture. And in this area, the focus starts, the earthquake, and then it goes up right there, which we call as the epicenter. So most of the earthquakes on Earth happens in subduction zones, and the one that is subducting is the oceanic plate because it's heavier. Again, we call the area where they have friction and where the stress builds up as the Benioff zone. The Benioff zone is found within the subduction zone of the oceanic plate. Now, this is another plate boundary. We call this plate boundary as the mid-ocean ridge. And in the mid-ocean ridge, these two are moving away from each other because of the convection current happening in the asthenosphere. The movement causes the magma to rise and cool down here and form the youngest rocks on Earth. This is where the youngest rocks are found, and since they came from cooled lava, they are called as igneous rocks. So that's what's happening. Okay, let's look at this one. I'll turn on the camera. This is what is happening. Okay, so this is a model of the seafloor spreading. Now, the youngest rocks are here. As the seafloor spreading happens, which is a divergent boundary, this plate moves to the left, this plate moves to the right. The youngest rocks are here. I will be marking this. There it is. Or probably I'll be using the marker right here. So these are the youngest rocks. But just like anything else, you start as young and then you grow older. Look at this one. These are the youngest rocks. But because of the mid-ocean ridge, what happens is that the rocks move away from the mid-ocean ridge. Now the youngest one is the one here. This is older rocks. They've been young before, but now they're older. And then continuously moves like that until they are now the oldest rocks. Okay? So, the youngest rocks now are the one in here. So, the farther you are from the mid-ocean ridge, the older the rock. But what do you notice on the edge? See this one? It sinks. This is what we call here subduction. So, this one sinks. And this one is melted. Just like what I showed you in the Benioff zone earlier. Same as here, it sinks. So even though that the Atlantic Ocean is getting wider, Earth is not getting any bigger. Why? Because the new rocks formed in the mid-ocean ridge become older as the ridges move, and when they become so old and reach the other side of the planet, that old rock now undergoes subduction, where it is melted and recycled into new rocks. So Earth is not getting any bigger, even though that new rocks are formed in the mid-ocean ridge. Because on the other side of the planet, the old rocks are melted in the subduction. That is what is happening. So mid-ocean ridge create new rocks, subduction, destroy, not necessarily destroy, but recycle the rocks by melting them. Okay? Now, even in other sides still, like between India and Eurasia, some rocks, they collide. But neither of the plates sink because they have the same density. If they are both continental crust, let's say this is a continental crust, this is also a continental crust, so neither is heavier. So what happens is, when they collide, just like what's happening between India and Eurasia, when they collide, this is what happens. See the formation of the mountain right there? So the land rises, and this is what's happening actually in Mount Everest. Mount Everest is still rising because of the continuous convergence of India and Eurasia. And again, just like what I said earlier, neither sinks or neither one is subducted because they are both continental crust. Okay? So that is what is happening. So, now, I'll be turning off the video.